thank you everybody for joining us. This is the GIS and BIM integration talk. I actually need to look up what it's called in the program so that I can correct the title before I upload the slides for you all. But anyway, I am Chris Andrews. I've been at Esri for about a little bit under 5 years now. I started off as the product manager for 3D across ArcGIS, and then I've gotten myself into trouble with a lot of other things, including BIM and GIS and defense products and all kinds of fun stuff. With me is Don Keeney. Don, go ahead and introduce yourself.
I'm Don Keeney. I am a product manager also. I work with Chris, where I've been working at Esri for the last 26, 27 years in the area of CAD and ever increasingly BIM and AEC workflows.
And then this is David Alvarez.
David Alvarez. I'm a product engineer and just a year and 2 months with Esri.
Cool. Sorry. All right. So we are. Do I dare touch it? I don't know. All right, that should be good. So we're going to cover today in an hour kind of a bit of a discussion about what some of our motivations are for working on CAD and BIM and GIS integration at Esri. We'll touch on some different product efforts that we're doing. I can talk a little bit about what Autodesk has done and a little bit about that partnership, and then we'll wrap up with some demos and then some Q&A. Anything else, Don, before I jump in? Okay, cool. All right. I always include this because I came from companies that were a little bit more formal than Esri, but just be aware that we'll sometimes talk about stuff that will be in the future, and don't take any future statements about deliveries unless they're like this quarter or we give you a definite date as literal fact, please. So I'm the lead on this GeoEnabled Systems team, and I think you saw it hyphenated on Jack's slides the other day. And one view of GeoEnabled Systems are that they are unique workflows, complete workflows for users that may include users that are actually new to GIS, who don't typically use GIS or may not know that they're using GIS at all underneath. And this includes things like the new ArcGIS Urban, which launched last week and is a product for urban planners. Or urban planners are often architects by background, and they typically don't really work in a lot of technology, and they need lightweight tools that are geospatially powered and powered with other types of data, but that aren't actually GIS tools to them, right? They don't think about wanting to jump into GIS. Same thing with something like ArcGIS Excalibur. That presentation was in this room a few minutes before we came in, and Excalibur is a web-based, lightweight experience for analysts who want to extract information from oblique imagery, all kinds of imagery, actually, and in the near future, video and other things as well. So one view on the GeoEnabled Systems team is that we are a set of products that enable geospatially powered complete workflows for new types of Esri users. And then another view on the GeoEnabled Systems team is actually that it is the smart assets and project delivery story. So you can imagine that if you are the city of San Diego and you are having problems like I saw this morning with pedestrians running across the railroad tracks with their kids in tow when a train is coming, no joke, what you might do is you might actually want to start an initiative to study people running across the tracks. And then you're going to give some community users, maybe a specific community group that's worried about it, you want to give them ArcGIS Collector or Survey 123 to actually go out in the field and do some data collection, but they're likely not going to want to pay you the full sticker price for an Esri user to enable them to go out into the field, right? So what we've done is we've created a product called ArcGIS Hub that has a special licensing model that lets you start initiatives where you then can hand out licenses for almost nothing to citizens to go and community members to go and actually collect data using Collector, participate in surveys, and do other things in ArcGIS. From there, once you decide that you might actually need to do something, you actually might then compare that information against demographics from, say, community analysts so that you can actually decide where you're going to have the most impact. Then you may, once you decide on the where, in that case, then you're going to go into urban where you're going to start your urban planning process. After urban planning, then you're going to bid out a project to RFP because you need to create change in the city, and you're going to actually farm that out to some AEC or ENC provider. And at that point, they're going to be working in somebody else's products, right? They won't be working in Esri products to do design and construction activities, but through partnerships such as the Autodesk partnership, hopefully those users are using the same system of record content that you are using to build up your urban plan. After that, once they're done, they're going to submit documents back to you, and you'd like to actually use those maybe for operations and maintenance or for other uses in the city. So then you're going to take those docs back and you're going to load them in ArcGIS Pro and in other parts of the ArcGIS platform, or with like ArcGIS for AutoCAD, and you're going to bring that data back into your geodatabase environment, which might be online or it might be enterprise. And from there, the data is usable for a whole bunch of other things, right? We've got utility network in our group. We've got parcel fabric in our group. We've got things like ArcGIS Mission, which is useful for military, but it's also useful for public safety. You've got an event around a new building. Actually, you got Lollapalooza going on in Chicago. This was an event from last year. They used ArcGIS Earth, one of the other products in our portfolio, and they would have loved to have used ArcGIS Mission to both do line of sight analysis and planning around where they're going to stage people and teams, and then to actually conduct the event response or the event management out in the field. So if you look at the portfolio products that are in our group, we actually are trying to build out different parts of that entire smart cities and smart assets and then project delivery story. And we can't do all of it as Esri, so that's why we work with partners, and even we have APIs for customers to do things. Okay, so unfortunately I had to miss some of the great afternoon talks that you guys got to see yesterday, but I understand that there were some pretty heavy topics, such as the Conserve Half the World project that E.O. Wilson is doing, which is really cool because my master's is in ant simulation modeling and biology, and so it's really cool to see him up on stage. What we are faced with is a massive amount of change that is going to happen one way or another over the next 20, 40, 50, 60, 70 years. And this statistic I saw that actually was published last year, that the world needs to build more than 2 billion new housing units in the next 80 years to handle human population growth is just, I mean, that's mind-boggling, right? I can't even imagine 2 billion housing units, right? And then this other statistic that by 2050, we need 30 times the current amount of roads and rails around the world to support our activity, right? Well, and a lot of us think about like the long distance 2,000 kilometer rail projects, but actually if you think about expanding city footprints, urban footprints, there is there are two axes of expansion that are going on there, and that starts to multiply the amount of transit requirements tremendously, right? So it's fascinating that to do this, we are going to end up doing this to support human population growth and activity. And part of the whole point of Jack's talks is to say that we all have a hand in helping that happen sustainably. Part of sustainability is not just conservation, but is actually empowering people to use the right data at the right time. One of the things that happened after I joined the company and started surveying our user community is that the #1 priority request for the 3D product manager at Esri turned out to be BIM and GIS interoperability. And I have different weights of statistics that showed this, but one was, for example, in a group of our distributors, which are international channel community, some of them were given an opportunity to vote and spend money on virtual features, and there were 24 features on the list. One of those features was BIM GIS interoperability. The collective group spent 75% of their spend on BIM GIS interoperability, and then about 95% of total spend went into 8 of the 24 requirements. And if you looked at the 8, all but 1 was associated with the AEC BIM GIS story. So it was really interesting even early on here to see that this world that I had come out of at Autodesk and AEC providers, that it was really important to the Autodesk or to the Esri community. And you know what? A lot of folks inside Esri really didn't even understand or know that. Some of them couldn't spell BIM when I joined the company. So BIM is actually, one of the reasons that BIM is so interesting to owner-operators, the UK government, and many others around the world is that BIM is a process for collaboratively creating and using detailed information about built assets throughout their life cycle. So actually, if I can pause there, before I go on, I meant to ask this before you saw this slide, how many of you knew or felt you knew what BIM was? Okay, good. Is there anybody here who just like really doesn't feel like they know what BIM is at all? Okay, few. Wow, this has changed over the last few years, huh? Like the first year that we started giving this talk, it was probably almost inverted. It was pretty fascinating. It's fascinating to see. So if you're the UK government and you want to, you need to build £1 trillion worth of assets over the next 15 years, well, you can either choose to do it with a really inefficient process where you'll get 15, £1 trillion of inefficiently built assets created, or you can do it with a hyper-efficient process where you might actually get effectively 1.5 trillion pounds of assets created. That's one of the reasons why BIM is really taking off around the world. Real-world 3D is buildings and infrastructure. Right? We're in a building right now. We took airplanes and roads to get here. And when I got to Esri, a lot of people really thought, in the Esri community that I worked with, really thought that 3D was kind of schematic visualizations of Jello cubes and things like that. But there's a lot more real-world 3D data out there than there are schematic visualizations of Jello cubes. So we got a lot of demand almost immediately to try to do more with real-world 3D. And many people associate the concept of real-world 3D with BIM and CAD. If you look at the questions that people ask about cities, kind of like the smart cities story that I told you a little bit earlier, what you see is that people typically are asking questions that are right at the intersection of what's there, what is where and who is it affecting? And actually there's another one that says when is it affecting them and over what time scale. So those are really the axes that we are worrying about in this, that bring together BIM and GIS, and it's why we're investing very heavily in trying to make life better for those who need to use both of those types of data, which is pretty much anybody who does anything in any environment around the world these days. One way to view it is that BIM supplies detailed information about assets, and then GIS provides information about assets in the context of the built and natural environment. Right? They both provide information about assets today. It's just different types of information driven by different parts of the asset creation and management process. We created this slide a couple of years ago now to illustrate that it's really not a handoff. You're not typically handing off and forgetting about, say, the GIS information once you're over in the BIM world. It's actually a set of ongoing processes that are happening all the time, right? This building is operated continuously, and then occasionally they need to renovate parts of it. And they may actually have two renovations that are going on at the same time and overlapping. And so what you have is you have the blue circle going all the time where they're running some events, Comic-Con, the Esri UC, and then you have them kicking off painting jobs or other renovation jobs inside the building or outside the building. And those are spun off continuously, right? And that happens at the scale of this building, happens at the scale of a rail network, happens at the scale of a city. We see a lot of common pain points in the BIM and GIS world. It's difficult to combine BIM information with up-to-date GIS, which actually we've addressed that directly with working with Autodesk and InfraWorks, Math3D, and pretty soon Civil 3D. It's difficult to access GIS during design without data duplication. Again, we've been working to address these things with our partnership. But we do hear about these commonly, and actually what I'd say is what we've done with Autodesk so far doesn't even scratch the surface yet of what people are asking us to do. So we haven't solved any of these in entirety yet. But we did realize that to do it, we would have to work with others. So we started the Autodesk partnership, actually just a little over 3 years ago. We announced it a little under 2 years ago at Autodesk University. And Autodesk has a big booth here, and we work with Autodesk folks just about every day at this point. And we are considering working with others too. We're happy to. It's a huge effort to glue together companies, and so you kind of have to go one at a time. All right, so some of the stuff that we're doing now is we are, on the Autodesk side, is they're enabling engineers to access GIS data through direct connection to ArcGIS through tools like InfraWorks and Map3D, and then as I said, pretty soon it should be Civil 3D. They're enabling civil engineers and architects, or we're considering enabling civil engineers and architects to access GIS data during design and construction, and that's in some cases some of the same tools that they've already lit up, and then other tools that we're thinking about lighting up in the future, such as I've got ArcGIS for Revit mentioned here, and Don may address it as well. We are definitely looking at enabling GIS users to access BIM for visualization, planning, and engagement. This is where Don's going to talk a bit more about direct read of Revit and in Pro, and then we're looking at direct read of other formats in the future. And then we're also looking at field workflows and what we can do to enable the direct collection of geospatial information that's immediately usable in construction and design workflows. And so some of our existing tools are already work for that, and there are other things we need to do. I'll talk about this a little bit just because I'm very proud of it. We worked very hard to convince the team that we needed to actually invent a new data type to store architectural, structural, and MEP information coming from the architecture side of the business in GIS. So we actually invented a new layer type called the building scene layer, or I3S building layer. And that scene layer was released in Pro 2.3. Right now, the content created is sourced from Revit, but you can use it to put large models in ArcGIS and then stream them to your phone over the web through ArcGIS Online. And David will show us some great examples of that. Then some of the things that we're working on down the road include looking at reality capture workflows, and we're getting a fair bit of demand for those, both for emergency response, but also definitely for urban construction and design workflows. We want to integrate BIM and GIS together into planning and design evaluation workflows. So that's things like using BIM information in ArcGIS Urban, which is not yet there. And then we also want to provide tools for the executive stakeholders in owner-operators to actually see what's going on in projects geospatially through things like dashboards that allow you to look at information coming from, say, BIM 360 and your ArcGIS Online environment and others at the same time. Okay, so that's it for me, and I'm going to hand over to Don here.
Okay, great.
You just need to switch your slide deck.
Right. Okay, so Chris has gone through an excellent presentation on why we're doing this, and so what's Esri's part in that? And so that's essentially my job as I switch presentations here, is to give you a little update on what's Esri's play in all of this. And I'm pushing buttons randomly here to get it up and going. Okay, great. So I'm going to talk a little bit more about what's Esri doing in this space of BIM, right? And so one of the first things that, as we approach this subject, that jumps to a lot of people's minds, they hear, oh, Autodesk and Esri are working together, or we want to merge the whole disciplines of CAD and GIS together. One of the first things that people kind of jump to, and I think it's kind of a little bit of a trap, is that there'll be this one database of all of everything, and then magic things will just pop out of it in different ways. And so that's not exactly what I'll be presenting, as we go a little bit forward. And one of the reasons for that is, even though we are working on the same building, for example, or the same airport, or the same transportation system, the applications that we use to design and construct these things are optimized for those purposes, whereas those same objects, when you're using and operating them and you're owning them and you're working with asset management and work order management and you're running that thing, the information that you're working with is about the same thing, but it's really unique content. One of the things that we want to do is we want to make that information flow more seamlessly. So even in the realm of BIM, what is BIM data? And even if we narrow it down even further and say that it's an architectural design file, one BIM doesn't include anything that you didn't put in it, right? And so a BIM file or BIM data may be just the structural components of a building. It may be just a stylized idea of what the building could be. It may have as much stuff as we can possibly put in it in a record BIM. So knowing what's in the BIM model is going to help us extract and reuse that for different purposes. So that's one idea that we really want to stress, is that there's nothing in a BIM model that somebody with forethought and people didn't actually put in a BIM model. So what is BIM to GIS? What does GIS have to offer? So one of the things that GIS has to offer is it's a great place to pull information together, to repurpose it, to compare it one thing against another, to visualize it. And so we are going to kind of stay in that vein. And how can we really leverage the content of the BIM process and BIM data in that? So Chris showed a stylized wheel, right, of a simplified, this is how BIM and GIS works together. If we were to draw all the different connections to where in that life cycle you'd want to have access to GIS information, you'd see that it's just this big integrated, every line would go to every part of that wheel in both wheels, right? So why wouldn't I want information during the design process? Why wouldn't I want geographic context when I am planning something? Why wouldn't I want all that information throughout the whole life cycle? And so, at the simplest form, you could say that, GIS really helps inform that BIM process to make better decisions. And BIM is often the outcome, and the outcomes of BIM are these new infrastructure, these new assets that are the fuel for the GIS. So what is Esri going to do about it? We have a lot of voices that we listen to. BIM is a popular subject around the world, and we travel around and we hear all these different voices about what BIM could be and should be, right? So one of the reasons why this conversation is happening more and more now is that GIS has really become a 3D system. And so there's a place to start really working and using this information. And so there have been advances recently in ArcGIS and GIS as a whole to work with this type of information. And some of this can be seen here in the different streamable formats that Esri has put out in the last couple of years to deal with huge amounts of information. A lot of this information can be collected or is collected during the BIM process. Things like 3D objects. It's a format that allows us to stream complete cityscapes, millions of textured boxes that we can just blow through in a web browser or on our phones. Mesh looks really similar, but that's the continuous surface often collected by remote sensing or drone type of information, like you might be experiencing in Google Earth, right? It's the continuous surface of the globe. The idea of point clouds, being able to take huge amounts of LiDAR data that's sitting in a storage facility somewhere and make it come alive and give it that context to all these other different layers. We also are looking at coming up with a voxel layer, stacked layers of information that we can plow through. So we have these new places to put information. Chris already mentioned the building scene layer. Is a way to encapsulate an entire building and all of its elements as a single layer, and then be able to turn off and on layers and be able to browse the contents of a building and see attribute information that originated in authoring software. And so unlike the 3D objects layer, like on the left, where we're dealing about millions of textured boxes, we're needing to approach the problems where we have millions of things in millions of boxes. This was a research project where they shrunk the entire city of San Francisco and put it on the building rooftop of one of the buildings in San Francisco, dealing with that idea of scale. And so we'll continue to look at these different types of layers to hold this type of information, but we've got a lot of work already that we've done, and we have places for these things. So some of the integration patterns that we see coming out of this is the idea that the map or the 3D scene can be this geospatial index to all different kinds of business systems. Example here on the left, a company, a business partner that does a scan to BIM process. They also have their own viewer that they create. And we can create a web-to-web connection between the map, navigate to a place, and then jump into spherical imagery or something like that. Could be an asset management system. On the right-hand side, another similar type of web-to-web type of integration, using Revit-sourced content that has been served out in an ArcGIS web scene with its attributes and links to the original content in a content management system like BIM 360. So someone could be navigating the campus, click on some assets, and browse through the original contract drawings or updates to information, or could, like I said before, link out to work order management systems or asset management systems. Another fundamental set of patterns when we look at how can we add value to the BIM process is this idea that we're going to be working in both file-based workflows as well as services-based workflows. So I can use ArcGIS for AutoCAD as an example. Using ArcGIS for AutoCAD, I can download the free plugin, and then the AutoCAD user can start seeing things that other people can't see, right? I can connect to GIS information. I can create GIS content that can be stored in a file, and when that information comes to the desktop user, it's already organized as GIS data. I know that I can take any of that GIS data and serve it out, right? I can serve it out to the enterprise. So people out in the field with Collector for ArcGIS or Survey 123 or ArcGIS Earth or web scenes or web maps are working on and using this information within their organizations. ArcGIS for AutoCAD is that AutoCAD person's interface. So this idea of connectors, right? And that's bidirectional too, so I can leverage my resources in AutoCAD, AutoCAD users, AutoCAD department to help me manage geospatial data. But it also gives them that context where they need it in their design tools. And so that's a pattern that we can look to replicate, right? The idea that I'm in AutoCAD, I can reach out, pull in maps for context. I can be editing information in my AutoCAD drawing using my AutoCAD set of tools that I then just update the GIS with, because that information can be sourced from that GIS repository. So this idea of being in my AutoCAD or my other design tools, having access to GIS content, and being able to edit that when appropriate. Another example of this pattern from Autodesk. Last year they released their connector for InfraWorks. It's a similar idea, right? It's the same idea. I can be in InfraWorks and I can look for content. I can discover and browse ArcGIS Online, bring in map content and feature content, and even edit that information, right? Within my pre-designed tool of InfraWorks. And that's an Autodesk effort. And all of this information is the same information that the rest of the GIS enterprise is working with. So it essentially just enables the collaboration that's already going on in your organization and just makes more connections to your design people. So one of those specific things that Esri has done over the last couple of years is we have the ability to directly read a Revit file. We've had the ability to read CAD files for quite some time, and so in the last year or so, we've added the capability to directly read Revit models as GIS content. And we followed a similar pattern that we did for CAD. And so when you're in ArcGIS Desktop, say you're in ArcGIS Pro, and you browse to an AutoCAD file or a DGN file, we'll automatically open it up as if it was GIS content. So from the file, you can use it in geoprocessing, you can use it as layers in a map, you can simply say copy features and add it to a geodatabase. So there's this idea when you open it up, it's already GIS data. For unstructured CAD data, we'll organize it into geometric types, points, lines, polygons, multi-patch, annotation. If you use ArcGIS for AutoCAD, you can predefine how that CAD drawing should be interpreted. So we can have attributed ArcGIS feature classes in that DWG. Now, we could also, whenever you export data, we leverage that same format. So how many of you have been using ArcGIS Desktop and exporting data to CAD files? How many of you know you are exporting attribute-rich feature classes to all of your AutoCAD users as fully attributed GIS data, right? So if those people, all those people that opened your drawing were using ArcGIS for AutoCAD, they'd have all the attributes. They would be working with it as GIS data and could send that, edit it, and create it, edit it, and send it back to you. Now, when we talk about Revit, architectural design software tool that creates BIM data, right? That's very structured data. So in some ways, it was actually easier for us to work with BIM data because it's already organized into categories. So I explicitly have walls, windows, doors, floors, and I can make a one-to-one correlation between ArcGIS feature layers and Revit categories, right? And so that's essentially what we're doing. And why are we doing that? We find that really what people are doing in GIS can fall into two buckets, right? One of the first things they want to do is they just want to see it. They just want to see it in context. On the right-hand side is a project that my daughter, who is an English teacher in northern Idaho, was working on like building a new house. And she was asking, hey, Dad, you got some cool maps, you know, that we can work on this together with? And so she downloaded a free copy of SketchUp, and then she saw me using Revit, and she goes, I think actually Revit's easier. So she has an educational background, so she could download a free copy of Revit, and so she started drawing her house. And so she wants to put that in the context of elevation, right? Is her house going to be in the floodplain? What does the view look like out the front window? What does it look like as the sun goes over? She can do all of that for visualization. The other thing that people want to use that Revit content for is for its geospatial content, right? A lot of us have been getting floor plan data for CAD for years and years, and now this new source of information is going to be BIM models. How do we reach into that BIM model and pull out the things that we need to fuel our GIS applications? So it's a new source of features, but it's also the whole thing, right? I want to see my electric substation, the way it looks in the map. I want to see my railway station. I want to see the new airport addition. I want to see it in the map, in context. So here's a short video. I know that when I'm in Revit, I could add any custom attributes I want to objects within Revit. So owner-operators need to think about what potential uses could I have for my Revit content downstream. If I want to use Revit data for space management, I better take the effort to put room data in my Revit model, right? So in ArcGIS Pro, when I open up a Revit model, I added a couple attributes to the roof, a couple custom attributes. And so when I add that information to a layer, it directly reads it as GIS content. So I can just add it as a layer in ArcGIS Pro, and all that attribute information, including those custom attributes that I created, are available to me inside of ArcGIS Pro. And all of this information is GIS data. It's already been essentially converted when I opened it. And I can do things like geoprocessing. One of the geoprocessing tools that I have access to is export to CAD. So I'm taking GIS data and I'm exporting it to CAD. It just so happens that GIS data is actually coming directly out of a Revit model, and I'm exporting it to CAD. So what do I get when I take GIS data and I export it to CAD? I get attributed feature classes, right? So if I have a tool like ArcGIS for AutoCAD, when I open up that content inside of AutoCAD, these 3D CAD objects now, they're pure CAD objects, these are 3D meshes in AutoCAD, they are actually attributed GIS content. So these are 3D GIS feature classes. What else could we do, right? Chris mentioned on his slide earlier, we can continue to replicate this pattern. So whether it's Civil 3D or it's Revit, we can see that there are uses for this idea of designing in context, seeing what other people don't see. My daughter in northern Idaho wants to know what the elevation of this property is versus this one, and she wants to see that while she's looking at building or at purchasing a property, right? Every architect in the world would want to know that, right? I want to know what's my access to utilities. If I need to orient the parking lot so it drains into the storm sewer, where is it? A lot of that information is already in the GIS. So, what could I be doing in Revit? Well, a lot of times when I'm an architect, I kind of just design on the site. Where's the site? I don't know, it's 0, 0. And so I build a pretty building. But if I want that to come into geospatial context, we're thinking about ways to make it easy for you to use a map to locate your building while you're in Revit, so that when you do bring it into ArcGIS, it's already been geopositioned for you. So simple things like that, or those other types of workflows I talk about. What's the terrain look like here? I can use that as my base to build on. What is the floodplain? What is my solar potential? Where should I rotate the building? Those types of things. So, in a general sense, Esri is going to continue to pursue the idea that we have all of these files and we need to do a better job of reading them. So Chris also mentioned IFC is certainly on our radar as, in that BIM sphere. Being able to do the same thing that we do with CAD and Revit models, be able to do that with IFC files. I'll add to that list Civil 3D. And so we also need to be able to export information to those different formats for file-based workflows. The idea of a connector for any design software, right? Being able to generate GIS-ready content with my design tool. ArcGIS for AutoCAD being an example of that, or the InfraWorks connector to ArcGIS is another example of that. Information that when it comes into ArcGIS Desktop, it sees it as GIS data that's already organized. And being able to communicate back and forth with those plugins. But then also being able to work in a connected environment, whether that's Portal or ArcGIS Online, being able to collaborate via services, web services, things like map services, image services, feature services, location services, geoprocessing services, utility network services, right? We can keep adding to the list of the types of services that could be fueling design applications, but also design applications could be helping us to maintain. Right? So that we get to that vision that Chris was sharing earlier of that, that connected city, right? That's spinning off new projects and being able to work with their planning and having that information flow back and forth. So I have an asset view of my storm sewer system, and I have stored that in a utility network, and I'm designing a new extension to it, and it lands in Civil 3D, and then I want to design it, and I want to push the as-built button, and it updates it. That's the vision, right? We're a little ways away from all that, but that's really where we're headed. I did mention Civil 3D, and so one of our plans for the next next thing on our agenda is doing the same thing that we do with CAD files and with Revit files, and that we hope to do with IFC files soon, to Civil 3D data, to get more at those AEC entities, so things like alignments, survey points, things that have been previously hidden to us in the DWG, and exposing those and making those available just like the other feature layers that we get when we open the other files. Yeah, again, some of the things that we don't guarantee, but things that are on our next to-do list. Another, for people who are already using the tools in ArcGIS Pro, things like reading direct Revit models, one of the interesting ones, really more of a housekeeping type of thing, is two tools there in geoprocessing to copy a Revit model to a geodatabase. Be able to merge multiple Revit models together to create a building. So oftentimes you may have 50 different Revit models that make one single building. This will be a way to aggregate that information, create a scene layer of that, and then share that as a building scene layer.
What's your time frame for that?
That was 2.5. So that's on the docket for 2.5. I can't guarantee that it will make it, but obviously something that we need to do as a phase 2, right, to get all of that working. So that would allow us to create one building from a bunch of Revit models, or a bunch of Revit models to create a campus, or being able to put those all in one layer, a campus layer. Okay. And so with that, I think I'm going to turn it over to David if I've left him any time.
Yeah, that's fine.
Okay.
Mine is not that long. Number 3.
So David's going to
Hello.
show us some of this in action, right?
Oh, can you hear me? Okay. So first of all, credit. This is the Ohio State University campus. They're provided all the data for this. So they have an initiative, mostly it's for facility management and space management, of converting every single building in all the campuses to a Revit model. So they converted every single building into a Revit model. They have around 35 million square feet of properties. So right now, there are 60, 70% almost done. This is just a few of the buildings. So what we have here is a 3D scene. We're going to navigate a little bit. So this is a little bit of a mix of data. So the dark gray is a multi-patch. So I haven't uploaded the Revit file. And the gray ones that you see, those are coming from a new format. So the building scene layer package. It's basically coming from a Revit, and we're creating using IS3 to create kind of a package that renders way faster in the web. So we're gonna have created additional tools. So right now you just have a viewer, you can pan around. You have the traditional tools that were already on the scene viewer. So you have your daylight, so you can see kind of your shadow. So you can move your time, or it's Ohio, it's always cloudy. So let's go June, a little bit more sunny, and you can see the shadow that the buildings produce. So those are kind of the standard ones that are already there, but there's a new tools that came out on 2.3 release and now 2.4 release. So we're gonna start doing a little bit more exploring the scene. So here's the campus. As you see, right now it's rendering all the multi-patches and also the building scene layers. So I'm gonna go a little bit more into it. You have 3 different building scene layers. We have what we call now the Explore building. So here at the bottom, you can do the Explore building, and I selected this building. As Don said, the data is structured already, so we always know what it looks like, what we're expecting. So you can turn on and off things. So let's go and turn off the walls. You see that building, the walls weren't turned off. But here's a new really cool tool that it was developed. We'll just put the walls back and let's put the rooms. So here you can now slice your building. So in this case, we slided the building on floor number 2. Let's pick something so you can see number 5. So that's floor number 5, and we just want to turn off the walls. So here now you can see what that floor looks like visually. You're still moving all the attributes that came out from the Revit. So if we click on that one, that room is for this building, and the space ID is this, and the number ID is this. Another tool that came that it's really interesting is the Analyze. You can do some measurements, but I really like the Slice tool. So we're gonna go here, and we're gonna slice that building. Now let's go right there. It froze. No, there you go. Sorry. So you can go on down, slicing the building, but let's go move around here and expand it a little bit more. Okay, so if we go down, yeah, it's just, you don't see what's interior. So we wanna just start excluding some certain things. So let me go back here. Sorry. And select all my structural and electrical and Analyze. So now you can see now the walls. So let's exclude the walls out of the slicing. So if I go down, you can see that the walls are always retained. So this helps you another way of examining the building, the structure, how it looks like if you want to show people where they have to go. Right now, this scene has 22 building scene layers, and the rest of the buildings are multi-patch, but the goal is to just keep adding all the buildings to this scene. So the school will be able to share this scene, and people can inspect the buildings and look a little bit where their rooms they have to go. That's what I have.
Great.
Yeah, that's all right. We've got some time for questions, and then if I can still.
Yes, you can. Your mic back.
All right, so just looking back a couple of years, last summer, I guess a year ago spring, it wasn't possible to take a Revit model and bring it into ArcGIS and share it out over the web. And Don last summer was showing the Houston Airport example that where he had taken. Actually, the first one was not Houston, but was
Nashville.
Yeah, Nashville, where he had taken Nashville, converted it into 3D objects, so multi-patches and Esri's multi-patch layer, and then that into a scene layer. And then in the fall, winter, we added the building scene layer, and each step we're trying to make things work a bit better. Is this interesting to you guys? Is it, okay? Well, we can actually take questions now. We have time for some discussion, and we can do some more show and tell. But do you guys have any questions or comments about what you just saw? Yes, sir.
Question on OSU's effort to Revitize their buildings. Where do they start from? Where they started from to get their buildings into Revit?
So repeat the question first.
So you're talking about the effort, basically the whole story of the effort from OSU to create every single file, every single building to Revit. So the goal is basically for space management and facility management. It's twofold. If a new building is being constructed that is above, and don't quote me on this, above $1 million, one of the requirements is that the building has to have a Revit file delivered. One thing that OSU spent a lot of time, it was developing their standard of how the data needs to be delivered. Now, the second part, older buildings, is just students. They have a good program that they recruit students, internal students at the campus, and they train them. They give them all what they need to Revit training, and they explain them how to read the plans, and they start building every single building that way.
And so we have quite a few other partners and mostly partners that I've seen who are working on different types of workflows. There's a company called WIG in the UK. I'm not sure if anybody from WIG is here, but they actually scan with point clouds the buildings, and then they bring the point clouds into Revit, and they actually can model against the point clouds there to recreate the Revit. Trimble has a practice they call VDC. It's really scan to BIM practice, and they use their hardware to do the same kind of workflow. And Revit, I think they told me they'd done about 1,300 projects, and 85% of the data was Revit that they were generating out of that. So I mean, it's actually happening quite a bit where people are scanning buildings. There are both photogrammetric and point cloud based workflows. I think the more common one that I've heard about is the point cloud based workflow. But all right, the gentleman right behind had a question. Yes, sir.
But in what version, so for on the Esri, so you can directly transfer from the Revit file to the shape file, GIS?
What version of I3S?
Yeah, because currently we are on the version 10.4.1, so we have to transfer from the Revit to IFC, from IFC to
Pro 2.2.
So Pro 2, yeah, sorry, Pro 2.2 allowed you to.
currently, but we don't have Pro.
Oh well, but the tool to load Revit directly is Pro 2.2. So that's the tool. Yes, yes, sir.
Can you speak a little bit more about the BIM 360 to ArcGIS Online integration?
Sure. Actually, we've been prototyping it out and developing examples of it for over 2 years now. They're both web experiences, so you can use pretty common web development technologies to create a common interface with the two. The biggest complication is that there is not a common indexing scheme or schema behind both GIS and BIM repository. So what you get in the BIM world and in the GIS world often is per owner operator or per project specifications, just like what David was saying about OSU. So it's really tough to develop a boxed product offering that glues together BIM 360 and Esri that works for everybody. Yeah. So what we've done is we had developed by a couple of our distributors, and then one of our partners who actually we acquired last week, Brockwell IT, has developed a template that we're actually thinking about seeing if we can convert into like a solution template for people to use. But it's both systems use standard web integration technologies, and the toughest thing is the specifications behind and how do you map the stuff that you're putting in BIM 360 into the stuff that you also put in ArcGIS Online. And so we've got demoware that we custom built ourselves to a spec that we determined, and I've seen Capgemini and I've seen a few others build their own examples of it.
Yeah, the Italian rail company, Talfer,
Right.
they had a great example where they're owner operator and they just did it. You know, they had a way to tag each of the assets that they wanted with the documents that they wanted in BIM 360, and they just did it.
Yeah.
You're basically using your scene, your web scene,
Yeah.
to be able to link right
So,
into
like,
360.
Right.
Click on a building.
Yeah.
there.
So if we have Chris is asking me to click on something. So each one of these pieces of a Revit model, right?
Yep.
Or it could be the entire
Oh
building
yeah,
shell.
actually, if you
and that's
go back
exactly
to-
what he's done.
Go back to David's.
His demo is that, right? Is his version of that. 3?
Yeah.
3.
Yeah. Yeah. So it's doable today. It's just we don't have a standardized
So let me
like
turn off
productized
the
offering around it.
So in this case, I created a point feature that tells me all the buildings. I just basically a point feature extruded a certain elevation and created an R, and that basically tells me that that was a Revit file associated with it, and there's a link to each of those. That is tied to A360. So as you can see here now, I'm in A360, and if the connection comes, you will see the same building that we saw on the scene.
We have other business partners that are
Oh, there
connecting
it
into
is.
things like Maximo, right, to do asset management too.
Yeah, and so like I program JavaScript. I could easily do something like this. David was able to do it. I mean, it's actually not that hard. The trick is in BIM 360 is a deep document management system, right? So you've got to know which version you want to call up. And then going from an individual asset inside a web scene into that asset inside BIM 360, that takes another little tricky bit. So it's a little bit complicated by the nature of the fact that they're two different systems built for two entirely different sides of that operational and project workflow, and really it's the owner operator that really has got to set up the specifications to determine.
So it's doable, but it's a custom.
Today, yes, for sure, yes, sir.
That building explorer is great. If I could take it and apply it to, say, a petrochemical plant or that Crossrail 2 project discussed this morning, where for an architectural structure, I'm looking at site characteristics
Yeah.
as the information hierarchy instead of the AEC. Can I drive that from BIM across and it's interactive, or I got to customize on the web GIS side? In other words, I'm bringing the BIM model across, it's got all the structure in it.
Yes.
Yep.
But that interface right there, that's a building explorer, could be petrochemical plant.
Oh, I see what
yeah.
you're saying. Yeah.
That's just a helper tool if
Yeah.
you have floors.
That's nice, because it gives me a way of getting at the stuff on site.
Yeah. I mean,
You can pull out the layers too, right? Go pull out the layers, and so.
Yeah, I can do the layers. So
and filters, yeah.
Yeah.
Yeah, so the thing is, we started with one of the reasons why you've heard us talk about Revit a lot is not because, like, a lot of people just think that Revit is BIM, and it's really not, right? BIM is a process, and BIM has been expanded to include civil and infrastructure, utilities, other things. But we did start with Revit because it's the single largest source of BIM information from a common user community on the planet, right? And so that was the easiest target to start from. We are now looking at transportation and other data types. But petrochemical, I mean, some of those plants have literally 100 million unique little assets, right? So it's a bit of a.
The main question is whether the BIM spec can, in essence, define that interface in building explorer for different kinds of content.
Ideally, it should be able to, because it's really just mapping to a level concept that's in there. So yes, yeah, for sure. All right, yes, sir. Nice. Yeah.
So features in Revit are more complex than they are in GIS. When you bring it into GIS,
Yeah.
you have like a wall, a simple wall, have multiple faces. right? When you bring it to GIS, is there a mechanism by which you are able to limit it to maybe the exterior of the wall and that's what represents your wall, rather than
Yeah.
having duplicates of lines that represent
Right.
the same feature?
Right. So the question is like when you're in architectural design software, potentially those objects can be really smart. They know like when they're embedded into a wall that the wall changes shape and all that kind of stuff. So they have parametric behaviors. They're often made of multiple materials, not just the textures on the outside, but the wall is made up of studs and drywall and 3 other different layers of vapor and stuff. So when those go into ArcGIS, what do you get? It depends on, sometimes the objects are really complex and they do have lots of complexity in them. But typically you're going to get the outside of those walls. You could have a really complicated window frame. So I'm not sure the best way to articulate it. It's kind of like we get the fine view of the objects, right?
Yeah, we
so
always redefine geometry.
this is a Revit concept.
For a furniture, basically, you can represent it as a box or kind of a half chair, but in reality, it's like this. So we always read in this geometry.
But
But-
that geometry itself could be complex, and
Sure.
situations I want just this simplified
Yeah.
shell.
So we don't give you today the control to request that.
Yeah, and that's a great, that would be a great enhancement, right, to dumb down the complexity or to simplify geometries. But right now we're getting all of it, and then we'll, work on slimming it down if we need to.
We do get a lot of questions around like how can I get the building shell, and a lot of GIS people assume that they assume that a Revit has building shells, building footprints, floor plans, and what's the other one? There's another one.
Rooms and space.
spaces, yes.
And some of those
So-
it does have, but they're optional.
Yeah, and those are the kinds of things that the owner-operator needs to spec into the BIM process and output that they're going to accept as part of the final deliverable. So if the owner-operator didn't spec those in, then there's no magic way to create them. And building exteriors is one of my favorites. And actually, the way that we have implemented building exteriors is
If they say it's an exterior object
Yeah.
and they've coded it, we'll pull it,
Yep.
throw it into a bin of
Yep.
exterior things.
Right.
There's no requirement that you put like levels or meaningful floor names on things. You can put anything you want. And so
So if you
get
look at the example that we have there, is basically when they request the BIM file, they didn't specify that the rooms need to be bound. So the architects just start drawing the rooms and just put a default number, and you can see that the height of those rooms is the top part of the room is 141 feet. So one room, it's 141 feet height. So that's an issue that you're gonna start seeing on the Revit side when the specs are not defined. You're gonna start seeing some issues with the data that comes in.
Yeah, another way that we've said it is there's no magic, right? If you haven't set up what you want to get at the end, then it's a classic garbage in, garbage out problem. So that's something that we get a lot of questions about. Yes, sir.
So does that give you the opportunity for 3D geospatial operators? We do things like 3D convex hull.
Yes and no, because actually I will tell you that there is not one definition of, for example, a building exterior that meets everybody's needs. Some of them need to be watertight. Some of them need to include balconies. Some of them don't need the balconies, right? All kinds of things like that. Some footprints include the eaves. Others include only the place where the building intersects the ground. So it's that, again, that's part of why you have to spec this out in your process. It really is a classic garbage in, garbage out problem. And if you don't control what's going into your process, then you're not going to get what you need out of it at the end, for sure.
yeah, and so we're going to get what's in it, because we don't want to miss things, right? And so we can be smart and clever and try to interpret what you mean, but I don't think that's our job.
This young woman has a question.
Autodesk has like a BIM software. Is this different or is it enhanced?
Yeah, so great question. Autodesk definitely makes BIM software. I used to work there and helped make BIM software. So it's kind of like the right tool for the right job, right? Engineers and architects need to be able to create. So the process of architecture and engineering is digitized to some extent, but not truly digitalized. They still need to produce stamped drawings, certified documents, sometimes digital, that they submit and that are legal record, right? So one thing that I've pointed out to many people is Esri is not making products that can allow you to end up with stamped drawings and documents, right? That's not what we do. We do allow you to manage legal information for things like parcels and other things, which have a completely different workflow. I think there's a half hour between the two talks, so I think we're okay. But then other people get confused by things like the fact that we're rolling out cut and fill tools. So is the cut and fill tool that we roll out going to, is that competitive with Autodesk? And is Autodesk going to get mad at us that we rolled out a cut and fill tool? Well, no. Actually, one of the funniest things was Don and I got that question. There was a big discussion about it. And then the very next day, somebody posted a simple snippet on Twitter about cut and fill. And the first person to jump on it and say, I can't wait to use that in Pro, was actually an Autodesk sales engineer in Europe. Because he sells into customers, or he works with and helps customers who have engineers and who have other folks like GIS staff who both want to use the same terrain information in the tools of their choice to extract information that helps their job, helps them build reports, make decisions, create visualizations. And yes, they could all work in Civil 3D or in Pro, but the reality is both of those tools are huge toolkits of many different tools that have been optimized for workflows fit for engineers or GIS analysts. And there are going to be overlaps, but they're not competitive because it's just different people using the same information for different outputs and purposes. And that's at the heart of the whole BIM GIS interoperability story. So just because a building appears in GIS doesn't mean that you're going to be doing architectural design or even, in most cases, architectural analysis in GIS, right?
Yeah. And just to be clear, all the structures and buildings that you've seen in this presentation were authored in Autodesk BIM architectural design software.
Right.
Right. We didn't create any of those buildings. We're just displaying the content in a geospatial context.
Right, and people are doing with other types of data too. The HNTV guys, I'm not sure if Darren or Jeff are here, but they showed a fantastic example of a custom JavaScript interface that they had built in their company, where they had brought in Bentley MicroStation information for roadways and bridge overpasses, and they had actually created a 5D project visualization tool dashboard where you could see the cost curve throughout the construction time, and then they actually could select things and isolate them out of the calculation so that you could see how the cost curve would adjust based upon whether or not you were including that asset. I mean, that's something that a close colleague of mine from a few years ago first conceived of at Parsons Brinkerhoff and built some videos and examples around, and really set the bar for what he wanted the industry to do. People got very excited about it. It was very hard back then. And here we show up and we both feel like, I'm sure, that it should have been on the main plenary because it was really freaking cool. And that's something that we didn't even do. And in that case, it actually wasn't Autodesk software, Autodesk output. That's okay. We definitely want to help people make the most out of their data, regardless of which environment it comes out of. But yeah, that question's very much at the heart of why we need to do BIM GIS, is people need to use the same data for different purposes and workflows. And they're not going to use the same tools for those purposes and workflows. So, good question. Are there any other questions? Yes, sir.
I just had a comment that the Ohio State and several other BIM specs are actually online.
Yeah, that's right. You can go out, although the heterogeneity and the detail of BIM specs is extremely variable, right? So some will say it needs to be spatially located using GIS software, and that's all it says, right? And then others will go down to very, very tight detail, but very cool. Thank you. All right, thank you, everybody. It's a pleasure. Thanks, Don. And David.